Okay, the simple regression model. So this chapter is about the regression model. It's the beginning of regression model, and we will use only one variable. That's why we call this a simple regression model. So definition of a simple regression model is explain variable y in terms of variable x. So here, even though we said it's explained, or you can predict variable y using variable x. That's the same thing. Can I explain the something y in terms of something else, which is x? So this is the definitely we can tell. Can we explain something with something else? So a lot of case, sometimes we can something is not easy to measure, but it's pretty much explainable by using something which can be easily measured. So maybe we can just measure the easy one, and then we can just predict or estimate the other one. So since this is the linear regression, so the prediction form will be the linear form. This is the intercept, and this is a slope, and this will be our error term. Some textbook use epsilon or e because this is error. Because our model will not be perfect. Or any statistical model is not perfectly predict our outcome, so that's why there should be an error. So why we call it a dependent variable, because y value depends on the x variable, right? That's why x is not depends on the y. X is just a number, it's given, and then using x we trying to explain y or predict y. That's why x is independent and y is dependent, because y value depends on the x. Explain the value, because we trying to explain y using x. It's a explanatory value is x, and so on. It can be a response variable and so on. So there will be a lot of different one, but so one thing is confusing is a dependent and independent. But we are trying to calculate y using x. So x is not depends on y, but y depends on x. That's why it's a dependent variable. Y is a dependent variable, and x is an independent variable. Interpretation. What is the interpretation of the beta 0 and beta 1? So beta 1 is basically the slope in the line, because our model was like a y equals beta 0 plus beta 1 times x plus u or LE. So this is the our slope. So how much x1 increase? This x increase by 1. How much y increase? That's basically the beta 1. That's the slope of the line, and that's the definition of slope. How much y will change when x change by 1? Okay. This is the how we explain how y varies with the change in x. So that's why when we divide it, what we get is a per x, right? This is a delta y per delta x. As a result, what we will get is the how much the y change in 1 unit increase in x. Yeah, how much dependent variable change if the independent variable increase by 1 unit. Yeah, because we divide by the delta x. This interpretation only correct if all other things remain equal when the independent variable is increasing by 1. Why this should be the 0 is the error cannot be changed by x. So if error can be explained by x, that is not an error, right? So here beta 0 should capture all the effect of x. So if you have something is non-zero, if delta u over delta x is non-zero, which means the error term, u term, can be explained by x somewhat, which means it's not a random error. So we can explain y because this u is still part of y, right? So if I can explain u by x and also beta 1 there, so which means beta 1 is not fully capture the effect of x here because the u also changed by x. So that's why this should be 0. U cannot be explained by x at all. That means it's a beta 1 capture the full effect of the x on y. So that's why this should be 0. Simple regression, linear regression model is rarely applicable because the simple, again, we are considering only one variable to explain y. That's why it's not that useful, but why we start with this simple, because we can explain a lot of different things. Still, we can use in the multiple regression. But when we start with the multiple regression, it's going to be really hard to capture the idea. That's why we want to have a simplest form. And then we will learn a lot of different concepts. And then once we got the concept, we can apply that concept to the multiple regression. That's why it's useful for the pedagogical reason. So example, soybean yield and fertilizer. So if you put more fertilizer, what do you expect? You expect you can have a higher yield, right? But how much? So that's what we want to know. So this beta 1 is capture the effect of fertilizer. But U will be depends on the rainfall or some other than fertilizer. There will be a lot of different factors that affect the yield. But other than fertilizer will go to the U. So U should not be changed by the fertilizer. That's why. In that case, it's a beta 1 capture the full effect of the fertilizer on yield, right? So wedge. If we want to know how the education affects the wedge here, so we can see how education affects the wage. So this is also we want to know the effect of the education affect the wage, but actually wage is not only on the education. It will be how many years of the experience, or what is the kind of contract, and what was the previous job he had, and so on, right? A lot of different things will affect the wage, but we want to capture what is the education effect. So assumption on the error term. So 0 means since the U should not be explained by the X, so expected value of U can be a little bit more, a little bit less. So our estimate of the Y should be in the middle. So maybe we have a positive error, we have a negative error evenly. So our expectation of the error should be 0. And homoscedas, this is really hard to pronounce. So homoscedasticity. This is the variance is not depends on the x. So variance of the error is same everywhere on x. Small x, large x, the variance of u is the same. Here the homo means it's the same, right? So it's not changeable by x. When x is greater, variance of u is not getting bigger or getting smaller. Okay. Independence. Independence is the each error happens here and there, but each errors are independent to each other. And also error follow the normal distribution. Since mean is 0, that's why this 0. So mean should be 0, and it has some standard deviation, and that is the error distribution. Then this standard deviation will not change by x. That's for assumption. We will see the some assumption later too. And causal interpretation. What is the causal interpretation? The conditional mean independence assumption. So error expected. Yeah, this is the same thing. Actually, I mix up some slide here and there. So expected value of u given x should be 0. What does it mean is the error should not be explained by x. Okay. So explanatory variable must not contain information about the mean of unobserved factor, which is the error term. Because we don't use that unobserved factor, so every other thing's effect is go into the error term. Okay, so for example, we wanna know what is the wage. I wanna figure out what is the effect of the education, but all other things is go into this error term. So this should be 0. I mean, expectation is 0. Some have a positive error, some has negative error, and so on. So average should be 0. Otherwise, if you don't have an average 0 here, actually you can put something taken out so that you can make a same expected value error, make it 0. So if you estimate beta 0 in wrong way, then actually you can have a expected value of u can be non-zero. Then you got something wrong here. And if u is just change by x, then you got a beta 1 wrong. So if you want to take it out all the effect of the this intercept and the slope, then everything should be taken out, and u just contains only the other factor we don't know. So expected value of u should be 0. Okay. And population regression function. This is the same as like a population data and the sample data. So when we do the regression, again, we will use sample data. We cannot have a population data. So population regression function is the real regression function. If we use a full data, population data, then we can get a regression function. That's a population regression function. Okay, so this is the as you can see, expected value of y given x is this way, because the expected value of the u will be 0, right? So expected value of y should be this one. So this means average value of the dependent variable. Y should be average value. So we can have a like a line which is the regression, but y is not exactly a certain point when x is given. Y is not exactly this point. This can be here and this can be here and here, right? However, the mean should be here. Mean should be on the line. Okay, so it can have some kind of distribution, but mean should be on the line. So we are trying to find out the regression line that will give you the mean value of y for given x. Okay, so something like this. So we wanna predict the mean value, and then draw the straight line here. This is population regression function. Of course, exactly same as the population mean and standard deviation, we will never know what will be the population regression function, because we will never have a population data. So using the sample data, we will do the regression. We will develop the statistical model, which is a linear statistical model, that's a regression. And then we will estimate our population regression function.